Just realised I didn't use any of this. I mean, well, now that's a waste. Now I'm going to wash it out. It's dissection day. We've done the theory, we've looked at how the heart is put together and how the blood flows through it. Now it's time to have a look at that as a whole organ all put together. If you need a refresher on any of the theoretical stuff, there's a really excellent video and linked in the description down below. Otherwise, let's get straight to the lab and let's get on it. I'll see you on the other side. So here I have a fairly standard dissecting kit. Got my tray, got my tools. We've got scalpel, scissors, C-Cure and a pair of forceps. We've got a couple of these rods as well we're going to use to sort of show the various vessels and stuff within the heart. Before we start, I'm going to glove up. Here's my heart. Right, this is wrapped up. So we'll dispose of this in a safe and clinical manner by putting it straight in the bin. Right. Here's my heart then. So, the first thing we want to do with any dissection is to get the orientation right, particularly important with organs, right? We're looking at a whole organ here. We've got to know how this sits within the organism before really we can do much with it. So, the first thing to notice really is this line running straight down and diagonally across the heart. This is really prominent, and if you look around the heart, there's no equivalent on the other side. So this is known as the coronary sinus. This is where the coronary artery, the main artery feeding the muscle from the heart, runs down and across the front of the muscle tissue. That's going to be our guide. So this is the front of the heart. This is a sheep's heart. So it would sit in the sheep kind of as I'm holding it now. Not dissimilar to the size of our hearts. So that's roughly how that would sit in my body. So this is going to be our guide. So we're going to separate the right and left side of the heart. So we're going to make two incisions, one into the left and one into the right hand side of the heart. And we'll have a look through the different chambers from there and try and track the blood flow. So first things first, we're going to lay it flat on the bench. We're going to go in with a scalpel to start with. Don't overuse the scalpel when we're dissecting. Generally, scissors are more useful for thick and difficult tissue. Scalpel blades are incredibly delicate, and once this breaks inside your specimen, then you've got a problem, right? With this sharp blade embedded somewhere in some muscle tissue, not ideal. So, you guys now have the pleasure of watching me dissect this heart. And it's just occurred to me that I've only been given one of these. So if I get it wrong, this is now the face of a man who realizes he's got one take. Good. Okay, we're going to go into the right-hand side of the heart first, right? So we've got this orientated face up on the desk. So the left-hand side, as I look at it, is the right side of this sheep's heart. We're going to use this coronary sinus as our guide, and then we're going to make an incision about 1 centimetre to the left of the coronary sinus, all the way down from the top, straight down into the lower chamber here, the right ventricle. So, cut through the fatty tissue. This hard white stuff on the surface is fat. A bit tougher to get through, and then you can feel the muscle underneath. Gentle strokes with the scalpel. We don't want to be sort of sawing away when you're dissecting. That's how we break blades. Gentle strokes. Once you get through the muscle, you'll see the chamber underneath open up. So we'll go all the way down to the bottom and through to the top. It's reasonably thick muscle tissue, but we'll put that into a bit of context when we get to the other side. Just separate that. Okay, so we can see here, the chamber that we've opened up here, this is the left ventricle, right? And you can see the thickness of the muscle tissue here. This is just under 1 centimetre thick in this particular one. Possibly not the fittest sheep in the world, but decent amount of muscle in there. This is all muscular tissue on the inside, so you can see the smooth muscle. And we can see the beginnings as well at the top here of the heart valve. So this would be the atrioventricular valve on the right-hand side, the tricuspid valve. So this then is pointing up through the atrium. The atrium is sort of under this flap of tissue at the top. This is reasonably intact, actually, this heart. Quite a lot of the ones that you will find for dissection, particularly that come from the butcher, have been cut up pretty nastily. And you end up losing quite a lot of the heart. This is a pretty good one, so I've stolen it for myself. The atrium is kind of under this flap of muscular tissue up here, in from that blood vessel in here. This is the right ventricle. We can see that. So we have a blood vessel coming down through the top of the heart that will come down into the right-hand side. Right, so we can follow that blood vessel all the way through from top to bottom. So we can see that blood vessel coming down through the top of the heart and into the right ventricle. This blood vessel here, this is the vena cava. So the vena cava is bringing all the blood back from the body into the right atrium, which is then passing down into the right ventricle. This rod now is passing through that tricuspid valve as it goes between the atrium and the ventricle, and you can see that now emerging in the ventricle down here. That blood then is going to be forced out from the ventricle, of course, through the pulmonary artery and off to the lungs to be oxygenated. This is a relatively thin muscular wall on the right-hand side of the heart because we don't have to send the blood very far. So only got to get from the heart in your chest to your lungs in your chest. So not a huge amount of pressure needing to be generated by the right-hand side of the heart. And so we can be reasonably thin in terms of the muscular wall, and far better to invest that muscle in the left side of the heart, which has got to get the blood up to the top of your head and all the way down to the bottom of your feet and back again. So from the ventricle then, we're coming out through this blood vessel here. Right, we can see that we've gone up through the ventricle and out through this blood vessel. This blood vessel is then the pulmonary artery. So this is the pulmonary artery that will take blood out from the right ventricle and through to the lungs. You can see the difference between the arteries and the veins here as well. We've got thick muscular walls on the arteries to withstand that pressure generated by the heart, and the veins coming into the atria down here, these are relatively thin walls, fairly low pressure through the veins, and a nice thick resilient wall of the arteries. So after the blood's gone to the lungs, gets refreshed then with that oxygen through gas exchange, it's got rid of all the carbon dioxide, we've got nice oxygenated blood going back to the heart, and we're going to swap sides. So we're now going over to the left-hand side of the heart. That's where all our muscle tissue is, and that's where we're going to generate the power to push the blood all the way through your body. So, again, we've got a flap of muscular tissue that's covering up the atrium, and that's going to come under here. So this flap is covering up the left atrium, and we've got the pulmonary vein coming in here. Again, you can see the relatively thin walls of the vein into the left atrium, and if I push my rod down in here, I can feel it pushing through a valve there and down into the ventricle, and then you can feel the rod at the tip of the heart. So if you are getting a chance to actually dissect this in the lab, you can push the rod all the way down through the valve. You should, if you hold the heart relatively steady, you should, and a little bit firmly, you should be able to feel it pass through the valve, and then when you feel a bit of resistance at the bottom, you can feel the rod down at the bottom of the heart pushing against the apex. So if we reorientate our heart down back onto the tray again, we've got this sinus running top right to bottom left again. We're going to now swap sides. We're going to look at the left side of the heart. So that's now on my right-hand side. We've got the front side facing up. Again, we're going to go about 1 centimetre to the side of the coronary artery, and we're going to make that incision down now through, following the line of the sinus, all the way down through the left ventricle. Now immediately here you can feel the difference between the left side of the heart that I'm cutting now and the right side that I was cutting before. Even with 3 passes of my scalpel here, I'm still not through the muscular tissues. It's a really thick wall just to generate all that extra pressure. So we've got to get through the muscle. As soon as you feel a scalpel go through the muscle, you can just sort of prise the muscular walls apart. You can see when you've got through and just extend that cut down towards the apex to open up the chamber. Nice gentle strokes with the scalpel. And again, extend up towards the atria, away from your fingers. Gentle strokes. We don't want to saw, and we don't want to put pressure on the scalpel, just a gentle push. We'll open up this side of the heart all the way to the top. Okay. So we now have a complete opening here, right? I've left a couple of bits intact here just so we can see how everything is attached in 3D. We have ventricle down here. You can see the difference in the thickness of the muscular wall, right? Really thick, strong muscle on the left side, relatively thin muscle on the right side, just because of the requirements of pressure between the two. We can see the soft tissue of the valve here that's still attached by these tendons. These are what's often referred to as the heartstrings. And again, if we went down through the vein, through the atrium, down into the ventricle, and you can see how that flow of blood would come down into the ventricle there. As you leave the ventricle, so as the ventricle contracts, we've got another valve. This is in behind this sort of wall here, and if we push up through that valve, you'll see, there we are, the rod emerging at the top of the heart. So that blood vessel that the rod is now poking through is the aorta. So we're going through the semilunar valve, up through the aorta, and the blood would leave there. So on top of the heart then, just to recap, we can see the 4 blood vessels, 2 veins going into the 2 atria, and the 2 arteries, one coming out of the right-hand side going to the lungs, this is the pulmonary artery, and one coming out of the left side to the body, and this is the aorta. So this aorta would then curve down and form a major blood vessel down to the core of your body there. So there you have it, there's a heart dissection. Key things to be looking at when you are actually dissecting. We must be checking the thickness and the strength of the muscular walls. There's a really key comparison between the 2 sides. We also need to have an understanding of how valves prevent the backflow of blood and look at the structure of those. How does that structure prevent the backflow of blood from the ventricle to the atria or from the arteries, the aorta or the pulmonary artery back into the ventricle? If we can look at the structure of those, you can see the flaps and how they should attach onto the muscles and how when they're closed, you can see that would prevent blood being forced backwards and causing big problems. We also need to have an appreciation of the blood vessels on the top. We should very clearly be able to see 4 blood vessels. We should be able to label those. Use the flags when you are dissecting to label the 4 blood vessels and take clear photographs of those as well. And that's just about it. So your dissected heart should be fairly clear. You should only need to make 2 incisions here. Scalpel is probably sensible for these. You can use the scissors if you find it particularly tough, but there's no real hard tissue to be trying to get through here. But gentle strokes with the scalpel, don't go mad with it. Try and keep that pressure on the scalpel low and keep moving away from your fingers, and you'll end up with 2 nice clean incisions into the ventricles. You can extend them up through the atria if you want to, just to see the structure of the valves. I'd advise that particularly on one side of the heart at least, and therefore you should be able to see the whole structure and follow the flow of blood around. Okay, once you've done the dissection, then important then to be looking at how that blood is being pumped around, so we look at the contraction of the heart, and that'll be what's coming next. So there you have it. Thanks for sticking with me all the way through. YouTube has now decided that you want to watch this. No? Okay.